Hello, I'm Fred. I'm the owner of Spraylock Concrete Protection and Spraylock Incorporated, the adhesive company. I've asked Josh to join us from the concrete side today because I want to talk about concrete moisture as it relates to installing floor covering. So one of the interesting things about the industry in general of floor covering is there's this connotation that moisture is a bad thing, moisture in concrete. And moisture in concrete is probably essential. But before I get off into the deep weeds, I'm going to let Josh talk about a little bit how moisture and concrete are somehow related and what's good and what's not good.
So from a concrete standpoint, we actually want that moisture in the concrete to prolong curing, to hydrate, to make your concrete more durable. By artificially trying to dry it, which I understand from a flooring perspective, you want that top surface dry and you don't want anything moving through it. But if you do that, you're actually reducing the life expectancy of the concrete. So from a flooring aspect, yes, absolutely surface needs to be dry. But from a concrete aspect, concrete being in that moisture being in the concrete is really a good thing for it to make it last longer so it can become more durable.
Now you're making a distinction between on and in.
Yes, sir.
Okay, so real clear on what those differences are?
So for concrete to get all the wonderful attributes we want, for it to be durable, for it to get the compressive strength, you need moisture in that. So the cement particles inside of it can hydrate and go through this chemical reaction to create new products that we want. It's kind of like baking a cake and not putting water in it. If you don't have that in there, you're gonna have a really bad cake. Very, very similar. I know it's an easy way to look at it, but from a durability standpoint, we want that moisture in there. We just don't want it moving through. So moisture being concrete is good. Moisture coming out of concrete is not great, but moisture going back in is really horrible for it. From a flooring standpoint, you do want that surface dry, which is why we have those moisture tests, such as calcium chloride and the relative humidity.
Okay, there are two main tests or three main tests to evaluate concrete moisture.
There is,
and are we talking about, once again, are we talking about surface or the concrete matrix? How do these tests relate to that?
most of the time you're gonna see two.
Okay.
There's a relative humidity and with in situ probes, and there's gonna be calcium chloride testing, which is the calcium chloride in a little dome shape that you put over it. Those are supposed to be testing moisture drive coming through the concrete. Unfortunately, when you're doing relative humidity, you're actually dropping that probe. So on a floor slab that's got a vapor barrier, you're only drying one side. What the standard calls for, which is ASTM F2170, is when you got it drying on one side, so top, you're actually putting that probe 40% into that concrete. So you're not getting surface relative humidity, you're getting relative humidity of the concrete. That doesn't mean it's moving through.
Okay, hang on here. So you're saying that the RH probes in the concrete aren't measuring what we've just discovered to be the all-important thing is movement.
Right. It's measuring potential of movement through, because that's all you're doing. You're taking a snapshot in time of the moisture, relative humidity moisture that's sitting inside that concrete. Doesn't mean it's moving through.
Okay, so it may or may not help you in determining whether or not you could have a potential moisture problem installing that flooring.
Correct.
Wow, okay.
Which takes us to the other test, the F1869, which is, I'm gonna read it, yes, I have cheat sheets in front of me. Measuring moisture vapor emission rate of concrete subfloor using anhydrous calcium chloride.
So, or what the industry refers to as the calcium chloride test. It's the little container of calcium chloride, and you put the dome on top, you seal it, and you wait a period of time to see what happens.
And it's a good test. Both these are good tests as taking, understanding what the whole slab's doing. I mean, I was a test man for many, many years and used them, but I took it as a whole. I don't take anything out of isolation. Really, you're supposed to put each one of these, whether it's the in situ relative humidity probes or the calcium chloride, 3 tests in the first 1,000 square feet and then 1 for each additional 1,000 square feet you have. You got a 100,000 square foot building. It's a lot of tests you got to put down. Majority of people aren't doing that.
No, it's not practical or
Not
affordable.
practical, or,
Yeah.
right. So you got a lot of costs on there, but that's actually how these tests are set up for. You know, so when you're doing these, there's a lot of things you can do from a testing standpoint to alter the way these tests are pulling up. The calcium chloride test is a desiccant. It will pull moisture from wherever it's at. So if you don't have it acclimated, if you don't have some other things going on, it'll actually pull moisture out than what's necessarily coming through, because that's what it's meant to do. You know, if you're trying to dry soil out, and I use that because, again, from my testing standpoint, and I wanted to get it completely dry without heat, I would use this, and it'll pull all the moisture out of that soil. So it's, bear in mind, I'm saying pull.
Right.
Not capturing, but pulling.
Yeah.
So you can actually have it pulling stuff out of the concrete. So you can get a test that might not be accurate, which is why you really need to do these things the way the standard's calling for, and understand that you're taking a snapshot at that moment.
So let me ask you this. So you got the calcium chloride test. Does it have a better probability of showing moisture or giving you an indicator of moisture movement coming through the concrete to the surface, more so than the RH, or not necessarily?
It's got a better potential to do that, but again, you're pulling it out. As a test man, for either one of these tests, if you didn't have your HVAC on, I'd tell you not to call me. Both these are supposed to be acclimated. And there is a section there that says if you cannot acclimate it to put it into these conditions. But for the most part, a lot of the times, you know, because of fast track construction, they're trying to jump on these floors quick as possible. So you might not have the HVAC on, which these tests are meant to have the HVAC on. Your adhesives are meant to have the HVAC on. Your flooring is meant to have the HVAC on. So these are only as good as the people running the test.
Right.
The other thing is for the calcium chloride, you're actually supposed to prep that concrete. It's not just go out there, clean it, throw it down there. You're actually supposed to grind it and open up that surface a little bit, because burnishing on the concrete will actually start trapping things in that over time, you know, you'll see it changing, because by the time you prep the floor, you might have opened some things up that you didn't get if you didn't run these tests properly.
Okay. Are there any other methods to
There is another
evaluate?
method that evaluates it. It isn't as quantitative, but it does give you quality. It was a test that people ran a long time ago. There's still some cases where it's being used, and it's just a plastic sheet test. Again, cheat sheet, because I like cheat sheets. So it's ASTM D4263. It's indicating moisture in concrete by the plastic sheet method. And basically you're just going out and taking a 4 mil plastic, 18 by 18, or I like 24 by 24, a little bit bigger area. You tape it down, you make sure that you pull the plastic through so that you're not going to get any air caught underneath it, and let it sit for 24 hours. Pull it back and see if you've got any moisture. If you've got moisture drive coming through, it's a quick way to see it. It's not quantitative, I can't give you a number on it, but it lets me know what's coming through.
You either have a moisture problem or you don't have a moisture problem. It's
And
pretty black and white. It's like
it is.
lights on, lights off.
But for me as a test man, I would let it sit 72 hours. That's where the other tests are sitting at, between 60 and 72 hours. Do the same thing there. It's not going to hurt you to go a little longer to make sure you don't have any problems coming through.
So, you being a testing guy and have lots of experience in the concrete testing side of the world, you got 3 tests here. You've got the RH probe, you got the calcium chloride, you got the plastic sheet test. What would you use if you really wanted to know whether or not you got a moisture problem in that slab when you're ready to put flooring down?
If I had to pick and choose one of the others,
Yeah.
I'd choose the plastic sheet.
Okay.
Just because it lets me know exactly what's coming through there. The other ones can be utilized, but again, you're taking a snapshot and you really need to take it as a whole, not as individual numbers.
All right. Okay. Thank you. Thanks, Josh. I appreciate you sharing that. And I thought you guys might enjoy this from a little bit of a deeper dive into the concrete side of things. Since we have companies kind of on both sides of the spectrum, a concrete treatment company that specializes in waterproofing the matrix of the concrete so that moisture movement stops. We want to keep the moisture contained in there so it stays healthy. But also on the flooring installation side with the adhesive company, while our adhesives have a tremendous amount of moisture resistance, there's always a slab from hell. And it sounds like the plastic sheet test is a great one to use if you just really want to know if you have a problem or not. So I thought I'd invite Josh here just to share this with you guys. And thanks for taking a few minutes to listen to this. Thank you very much.
Thank you.